fellow tech enthusiasts. Welcome back to my channel, Errors to Earnings. Hi, I'm Divya, and if you're here to master SQL, you stepped into the right place. So, in today's lecture, we are going to dive into something incredibly important, that is, database modeling or entity relationship diagrams, and how we are going to convert them into SQL table structures. So, whether you are building a database from scratch or just getting familiar with data modeling, understanding ER diagrams is very essential. So, let me break it down step by step. First one, what is ER diagram? So, ER diagram is nothing but entity relationship diagram. This is a visual representation of entities within a database and their relationships with each other. So, to put in simple terms, it is like the blueprint of your house. So imagine you are building a house. Then the ER diagram is like the floor plan and the tables are going to be the actual rooms in the house. So ER diagrams can help you organize your data logically and avoid chaos later on. So let's look into the components of ER diagram. So the first thing is entities. These are the things or objects in the real world that you want to store information about. Suppose, for example, these entities are nothing but tables. You can say that customers will be one of your entities. That means customers table. And the next one would be orders and products. So these are going to be the entities. Suppose if you consider a floor plan as your ER diagram, then the rooms in the house, be it the kitchen, bedroom, or hall, or dining room, so these are the entities. Next comes the attributes. So, attributes are the properties or details of an entity. Suppose, for example, in customers entity, we can have many properties like we are going to have their IDs, customer names, email, and all. So these are going to be the attributes. So let us consider this house example again. Now in hall you are going to place a lot of furniture, right? It may be a sofa here, and in bedroom you are going to have cupboards and all, right? So these are going to be the attributes then. Next comes the relationships. So relationships are the connection between two tables, or you can say that these define how two or more entities are related to each other. For example, a customer might place an order. Therefore, a relation is being established between customer and order, right? The same way, let's say how if I want to go to hall, there will be a direct door to hall. This bedroom is connected to the hall. So there is a relationship between bedroom and hall. In the same way, relationships work in the ER diagrams too. Next comes the types of relations. So now let's talk about the types of relationships between entities, which are the most critical parts of your ER diagram. So the first one is one-to-one. This means that each record in entity A is exactly related to one record in entity B. For example, let's say we can see that only one person can have only one passport. So they have the one-on-one relationship. Next comes the one-to-many. This means can relate to multiple records in entity B. So for example, a customer can order any number of products, right? The same way one-to-many works. Next comes the many-to-many. Here in many-to-many, entity A can relate to as many as records in entity B. So that means we can see that simply is a single student or group of students can take any number of courses, right? So they have end-to-end relationship. Now, let's look into the ER diagram symbols. So, these are the common symbols we generally use in the ER diagrams. So, rectangle represents entities and this oval, okay, this is not exactly an oval, but consider it as an oval, alright. So, this oval is an attribute and this diamond or rhombus is going to be the relationship, and this line shows these lines are nothing but it connects entities to their attributes or shows relationship. All right. Now let's understand with an example. Now let me walk you through an ER diagram example so that you could understand it very easily. So this is an ER diagram. So this generally represents the academics database. You can say that. All right. How students courses, subjects and lecturers are connected with each other. So this student is one entity. That means we have a student table, and this course is another entity. So that means we have a course table, and then we have a lecturer table, and we have a subject table. So number of students attends number of courses, right? So now you might have a doubt, aren't course and subjects are kind of similar? So now let me tell you the difference between course and subjects here. So in general, we know that maths has a lot of topics in it, right? Even for example, calculus. Let's take calculus. So we have many types of calculus. We have integral calculus, differential calculus, right? So if calculus is the course, then integral calculus is going to be one subject and differential calculus is going to be the another subject. So you got the difference between course and subjects, right? So now let's look into the one by one. So the first entity is student. So here in students, we have a lot of attributes. One of them being student ID, age, hobby, DOB, student name. And we have address. Again in address, there are sub attributes like door, street, city, state and pin. And of course, we have course ID, right? So now if we look into this, if whenever we underline a attribute, then this is called as primary key. So we are going to use student ID for student table as a primary key. And if there is a dotted oval, then this is the derived attribute. So why is it called derived attribute? Because it is derived from DOB. Let's say if the age is 18, we can simply say that today's date. So let's say this is 2025, right? And in my DOB, I was born in 2003. So how many years would I have? Of course, some 21 years. All right. So this is how derived attribute works. And then if there are double oval, that means if there are two ovals, then we call it as multivalued attributes. Why multivalued? Because simply observe here, hobbies can be a lot of hobbies. For example, I have hobbies like watching TV, surfing the net, doodling, mandala art, etc. etc. Right? So these are going to be the hobbies. Now, you can see the course ID here. Now, number of students, M to N, that means many to any number of relations. So suppose let's say two different types of students attend two courses, right? So students attend courses. This attend is the relationship between student and courses, and they have many to many relationships. All right. Now at the course, we can see that there is course ID and course name. So this course ID is the primary key of the course. And this course ID, whatever we have used in the student table, is going to act as the foreign key when we connect it with the course table. You got the point, right? Now, look at the course and subjects. So, a single course will have multiple subjects. Just the same way, in calculus, we have differential calculus and integral calculus. So, a single course will have multiple subjects. You got the point, right? So, there are one to many relationships. So this has is going to be the relationship. Now in subject, we are going to have lecturer ID, subject ID and subject name. This subject ID is going to be the primary key of the subjects. Now a student attends a particular faculty, right? So for a particular student, any number of teacher can teach. I mean, a student will have multiple courses, right? So you can say that single lecturer going to teach. So now if you look at the lecturer versus student table, so many lecturers teach to a single student. You can say that, right? Or think of it in this way. So I am Divya. So I am the student here. And now I have multiple subjects with me. So I'm going to take multiple subjects. I'm enrolled in multiple courses. Then I have each lecturer for each course. Let's say for maths, I have one. For English, I would have another lecturer. All right. So in that way, so there is the one to many relationship between student and teacher. You got the point, right? Next, in lecturer, we can see that we have lecturer ID, lecturer name, and the course ID. So this lecturer ID is going to be the foreign key when we connect both the lecturer and subject. So you got the point, right? How we are going to design an ER diagram, how a database is being modeled and all. So this is all about ER diagrams and database modeling. So if you enjoyed the video, don't forget to like, share and subscribe. Until next video, see you, bye bye.